Have you ever really stopped and wondered about the invisible forces that are, well, running pretty much everything? You flip a switch, a room lights up, you hit a button, a motor starts humming. It all kind of feels like magic, right? Well, today, we're going to pull back the curtain and look at the secret handshake behind it all, the incredible, powerful link between electricity and magnetism.
So here's the game plan. We're going to start with a total accident that turns science on its head. Then we'll figure out how to actually see these invisible forces. After that, we'll see how to control them. And finally, bring it all home to see how this stuff works in everything from giant motors to the wiring inside your walls.
All right, our story starts way back in the 19th century. Picture a university lecture hall. A professor is doing a demonstration, and something is about to go wonderfully wrong. It was one of those moments of pure luck that revealed a deep, fundamental truth about how our universe is put together.
You gotta understand, for the longest time, scientists thought electricity and magnetism were two completely different things. You had electricity over here, doing lightning and sparks, and you had magnetism over there, making compasses point north. They were like two separate clubs. The big nagging question was, could they be related? Could one actually create the other?
So it's 1820. A scientist named Hans Christian Ørsted is in the middle of a lecture. On his desk, he's got a wire hooked up to a battery, and just sitting nearby is a regular old compass. Now, the moment he flips the switch and sends current through that wire, something amazing happens. The compass needle, which is only supposed to care about the Earth's magnetic north, suddenly jumps. It deflects. In that one completely accidental moment, he proved it. Electricity creates a magnetic field. The two forces weren't separate at all. They were connected.
Okay, so Ørsted proved this invisible force is real. But that just opens up a whole new can of worms, doesn't it? Like, what does this force field actually look like? How on earth do you draw a map of something you can't even see?
Well, scientists gave it a name, the magnetic field. It's not a physical object. It's more like a zone of influence. It's the space around a magnet or a current where the magnetic push and pull is active. You put something magnetic in that zone, and it's going to feel it.
And what's so cool is how easy it is to see this in action. You've probably seen this before. If you take a simple bar magnet and sprinkle some iron filings around it, they don't just land randomly. Nope, they snap into this beautiful, perfect pattern of lines, literally tracing the secret architecture of that invisible field for us.
And these patterns, they follow a few simple rules. They always flow out of the North Pole and loop around back into the South Pole. They're always complete loops, and where the lines are all bunched up close together, that's where the field is the strongest. And here's a big one. They can never, ever cross. I mean, think about it. If they did, a compass at that exact spot would have a total meltdown, not knowing which way to point.
So, we know an electric current makes a magnetic field. This leads to a really fun question. Can we control it? Can we become magnetic field architects? What happens if we start changing the shape of the wire? Can we actually shape the field? Oh yeah, we absolutely can.
Let's start with the most basic shape, a dead straight wire with current flowing through it. The magnetic field it creates is super simple, just a series of perfect concentric circles wrapping around the wire.
And there's a ridiculously easy trick to know which way those circles are spinning. It's called the right-hand thumb rule. Seriously, you can do it right now. Just take your right hand, point your thumb in the direction the current's flowing, and look at which way your fingers curl. That's it. That's the direction of the magnetic field. A brilliant little physics life hack.
But things get way more interesting when we take that straight wire and bend it into a loop. All of a sudden, those circular field lines start to bunch up and reinforce each other right in the middle of the loop. And at the very center, the field becomes super concentrated, strong, and almost perfectly straight.
And if one loop is good, what about 100 loops? That's basically what a solenoid is. Just imagine a wire coiled up over and over again into a cylinder, kind of like a slinky. When you do that, you combine the power of all those loops to create an incredibly strong and amazingly uniform magnetic field inside.
Now, get ready for this, because this is the big reveal. If you map out the magnetic field from that solenoid, it looks identical to a regular everyday bar magnet. It has a north pole, it has a south pole. It acts exactly the same, and that's the whole point. We figured out how to create a magnet, an electromagnet, just by running electricity through a wire. And the best part? It has an on-off switch.
Okay, so making a magnet with a flip of a switch is pretty cool. But so what? What can we actually do with that? Well, this is where we turn a cool science trick into actual real-world motion.
So we have our wire, and it has its own little magnetic field.
Now, what happens if we put that wire inside the magnetic field of a much bigger, stronger magnet? Well, the two fields basically start arguing. They push and pull on each other, and the result is a real physical force that actually moves the wire.
And yep, you guessed it, there's another handy rule for this one. It's called Fleming's left-hand rule. Take your left hand, point your first finger in the direction of the main magnetic field. Point your middle finger in the direction of the current, and look where your thumb is pointing. That's the direction of the force. It tells you exactly which way that wire is going to get pushed.
Now just think about what that means. This one little principle, current plus a field equals motion, is the magic behind almost everything that moves in our world. It's how electric motors spin. It's how the speakers in your headphones vibrate to make sound. It is a force that we have put to work in a million different ways.
So we've seen how this force runs our gadgets. But for that to happen, the electricity has to get to them first. And that means this invisible force isn't just in your blender's motor, it's flowing through the circuits hidden inside the walls all around you right now.
Inside those walls, you've basically got a three-person team. You've got the live wire, that's the one carrying all the electrical juice. Then there's the neutral wire, which completes the circuit and gives the current a path back home. And finally, you've got the earth wire. This one's the bodyguard. If anything goes wrong and electricity tries to escape, this wire gives it a safe path straight to the ground, instead of, well, through you.
And the unsung hero guarding this entire system? The humble fuse. It's really just a tiny, special piece of wire with one very important job: to be the weakest link. If the current ever surges to a dangerous level, that little fuse wire instantly melts, breaking the whole circuit. It literally sacrifices itself to protect all your expensive stuff and your home from frying.
Okay, we've talked about motors, we've talked about wiring, we've talked about technology, but what if I told you that this very same invisible force is at work inside your own body?
No, it's absolutely true. Every single time you think a thought, flex a muscle, feel anything, your nerve cells are firing off tiny electrical impulses. And just like the current in a wire, those tiny impulses create their own incredibly faint magnetic fields. They're so faint, but they are real. So real, in fact, that doctors can use massive machines, MRIs, to detect those very fields and create stunningly detailed pictures of your brain and your heart. So think about that. The exact same fundamental force that spins a giant industrial motor is also at work mapping the very essence of who you are.